Our discussion for this video is all about algebra. We tackled for this topic radicals, complex numbers, quadratic equation, absolute value, and polynomial functions. What is an algebra? An algebra is like an arithmetic that involves on which are performed operations such as addition, multiplication, subtraction, and division. While arithmetic is concerned with operation on specific number such as 2 plus 5, 8 times 9, 43 minus 18, 36 divide 4. In algebra, we deal with operation on unspecified or unknown numbers that are designated by symbols or letters such as x, y, z, e, b, and c. Thus, in algebra, we consider as x plus y, a times b, y times z, b divides c. The word algebra originated from the Arabic word algebra, in which appears in the title Elm Algebra wal Makabala, means that the science of reduction and cancellations. Before we proceed our topic, we discuss first properties of exponent. The first theorem, quantity e to the power n to the power m is equal to a to the power mn. So n here is the exponent, e here is base, m here is the factor of e to the power n. So take note that e is the real number and m here is the positive integers. So for example, quantity 2 to the power 3 to the power 2 is equal to 2 3 times 2, so 2 to the power 6 is equal to 64. Then quantity x squared to the power 5 is equal to x to the power 2 times 5 is equal to x to the power 10. So next theorem, quantity of e and b to the power n is equal to e to the power n, b to the power n. For example, 2 times 5 to the power 3 is equal to 3 times 5, 3, result is 1000. The next, quantity x squared y fourth, quantity 5 is equal to x to the power 2 times 5, y to the power 4 times 5 is equal to x to the power 10, and y 20. That is the answer now. Next theorem, e to the power 0 is equal to 1, where e is not equal to 0. Any number or any variable, when the exponent becomes 0, automatic siya na equals 1 na siya. For example, so x to the power 0 is equal to 1. Another example, 4 to the power 0 is equal to 1. E to the power 1 over n is equal to quantity n root of e. For example, x to the power 1 half is equal to the square root of x. Another theorem, e to the power n times e to the power m is equal to e to the power n plus m. So for example, 2 to the power 3 times 2 to the power 2 is equal to 2 to the power 3 plus 2 is equal to 2 to the power 5. The result is 32. X to the power 4 times x is equal to x to the power 4 plus 1. So the result is x to the power 5. Another example, y to the power 3 times y to the power 7 is equal to y to the power 3 plus 7. The result is y to the power 10. So another theorem of the exponents, e to the power n over e to the power m is equal to e to the power n minus m, and where e is not equal to 0. For example, x to the power 6 over x squared is equal to x to the power 6 minus 2, so the result is x to the power 4. So x to the power cube over x to the power 7 is equal to x 3 minus 7, so is equal to x negative 4. So another example, x to the power 5 over x to the power 5 equal to 1. So because they have the same base, the same exponent, so equals 1. So another theorem, quantity e over b to the power n is equal to en over bn, where b is not equal to 0. So kung ma-0 siya, it is undefined. For example, Quantity 2 over 3 to the power 5 is equal to 2 fifth over 3 fifth is equal to, the result is 32 over 2 over 3. Quantity x to the power 4 multiplied by 3, quantity z squared multiplied by 3, so over y to the power 9. So the result is x to the power 12, z to the power 6 over y 9. So that is a simple rule of exponent, no? And when it comes in multiply. So nag-apply siya from this theorem to become the first theorem in the previous slide. So next, na-discuss na nito, no? So for example of that is 4 to the power negative 2, so automatic siya reciprocal. So the result is 1 over 16. So another theorem is e to the power m over n is equal to the n root of e to the power m. So for example, x to the power 1/5 is equal to the 5th root of x. Quantity 7x to the power 3/4 is equal to 4th root of quantity of 7x to the power 3. Let's proceed our topic, radicals. What is radicals? In the expression n root of e, n is called the index, e is the radicand, while the symbol is called radical or radical symbol.
This is the properties of radicals. So first, theorem. So n root of e to the power m is equal to the quantity. So we write with this, no, the n root of e. Then so m is the factors of n root of e. For example, cube root of 27 squared is equal to quantity of cube root of 27. So to the power 2. So atong gipagawasan to. So the answer is equal to 3 to the power 2 is equal to 9. Another theorem. N root of e times the n root of b is equal to n root of e times b. So for example, cube root of 6 times cube root of 36 is equal to the cube root of 6 times 36, so equal to 6. Another example, quantity of square root of x over cube root of x is equal to d. So atong gi-extract first, atong i-extract ang square root, and then we know how to solve in terms of exponent. So becomes so x to the power 1/2 over x to the power 1/3. So unsa man ang exponent ani, so subtract no kay divide mo ni siya. So equals to x to the power 1/2 minus 1/3. So nasubtract yung exponent, no. So dayon the final answer is as root of x. So another theorem is n root of e over n root of b is equal to the n root of e over b, where b is not equal to 0. For example, the fourth root of 100 over the fourth root of 25 is equal to the fourth root of 100 over 25. So 100 divided by 25, so equals 4. So the final answer is fourth root of 4. Another example is the square root of 4x cubed y squared z over the square root of 2x y z squared. Also the square root of 4 over 2 times x to the power 3 minus 1 times y to the power 2 minus 1. So na may y ang kanang denominator, ang numerator sad, so the same na y sila, so na y variable, so ang z sad na apod, so times z 1 minus 2. So the final answer is a square root of 2x squared y over z. Another theorem, m root of n root of e is equal to m root of e. For example, square root of cube root of 25 is equal to, so
times siya 2 times 3 square root of 25 is equal to the 6 root of 25. That is the final answer, no?
Another term, so di lang kay duha ra kabuk radical symbol, so pwede siya maupat, matulo, malima radical symbol na problem. So depende sa problem na pag-given. So for example, the square root of 4 cube root of x to the power 6, and then the square root of y squared z to the power 4. So first thing to do is we separate the sa ini is na square root man niya ang 4. So so we separate the square root of 4, and then nani siya ito diri, so pwede na to ma-times diri sa kwan iyang second na brought na radical symbol. Kaya mana no 2 times 3 dayon square root sa x to the power 6 dayon
So square root of y squared and z to the power 4. So mana siya no, mitabo. So atong kanang ang solusyon nato dre is anam lang. Then next is equal to 2 times the 6 root of x to the power 6. So kana pag-abot ato dre, hindi tama. 2 times 3 is 6. Dayon naka kano man nasod man siya sa 6 root ang x to the power 6. So automatic atong i-separate. Next ato sang i-separate, so nam tay 6 diri, so i-times na natog to because nam siya naka square root pa man ang y squared z4 no. So i-times man nato ani, so apil gyapon na siya. Then 6 root of x to the power 6, so makancel siya no, okay 1 siya. Subtract ang square root, may mo siyang 1/6 no, times ma-multiply siya, so makancel ang 6 mawa, so mabilin ang x na lang. So 1 into x na, so square root of 4 manang 2 then x, and then pag-awat diri is 6 times 2, so 1 into 12 no, 12 root of y squared z to the power 4. So the final answer is 2x the 6 root of y z squared.
because 2/12 is may mo siyang 1/6 ning extract na square root no. So sa diri is ato tang gi-reduce, so 2 para makakuanta og 6 root na kuan, so ma-the-same sa y, so dapat mabilin to diri. So mao na ang final answer. Next, another theorem of radicals. Quantity in root of e to the power n is equal to e. So for example, quantity of cube root of 4x, so multiply by 3, so automatic makancel siya, automatic the result is 4x. So another theorem, in root of e to the power n is equal to, where e is if n is odd, so unsam tong odd na number, so katong ko 1, 3, 5, 7 and so on. Then absolute value of e if n is even, so unsam tong even na mga numbers, so those mga even numbers is 2, 4, 6 and so on. For example, cube root of quantity of -15 cube, so makancel no kay puro sila 3, so the result is -15. So where n is a number, so automatic di wala siya absolute no. And next example, fourth root of -12 to the power 4, so absolute value of -12 is, the result is 12 because n here is a even number. So kini basihan na to, n here is equal to 4 but n is an even number, 4 is an even number, 3 is an odd number. Another example, square root of quantity of -x to the power 2 times y minus 3 is equal to the quantity of -x to the power 2 times the y minus 3 to the power 1/2, and then is equal to we extract we remove the square root sign or radical sign, then we distribute the 1/2 and 1/2 to each this, so quantity of -x squared to the power 1/2 times the quantity of y minus 3 to the power 1/2, so absolute value of -x times y minus 3 to the power 1/2, so the result is x square root of y minus 3. So
In radicals, we also talk about surd. So what is surd? Surd is a radical expressing an irrational number The sword is described after the index of the radical. For example, square root of 3 is a quadratic sword. Cube root of 3 is a cubic sword. Fourth root of 3 is a quartic sword, and so on. So, the pure sword, sometimes called as entire sword, contains no rational number and all its terms are swords. For example, square root of 3 plus square root of 2. So, that is the pure sword. The term mixed swords contains at least one rational number. So, for example, 5 square root of 3 is a mixed sword because 5 is rational number while square root of 3 is a sword. So, another term of sword is the binomial sword. Expression of two terms with at least one term is a sword. For example, 5 plus square root of 2. Another term, trinomial sword. So, it's an expression of three terms with at least two of them are swords and cannot be expressed as a single sword. Otherwise, it will become a binomial sword. For example, 5 plus square root of 2 plus square root of 3. So that is called the trinomial sword because they have three terms.
Let's talk about another example, the radical. Okay, simplify each of the following radicals. So we have a solution here. Example, cube root of 81 x to the 4th y cube is equal to the cube root of 3 to the 4 x to the 4 y to the 4 cube. So first thing to do is kuha na to ang prime factors of 81. So nganon na yan siya, nganon 3 to the power 4 siya. Let's see this. So 81, so 9 times 9 is 81. So prime factor of 9, 3 times 3 is 9. Another 9, 3 times 3 is 9. So, upat ka 3. Mo ng 3 to the power 4. So, yun. Cube root of quantity of 3 to the power 3, x to the power 3, y to the power 3, times the quantity of 3x cube root of quantity of 3 cube, x cube, y cube, times the cube root of 3x. So, you know, we have an individual exponent of 3. So, makancel siya, no? So, ang mabili ni is kini. Ato lang gi-separate siya. So, the final answer is 3xy cube root of 3x. So, another example. So, cube root of 126 r squared e squared t times the cube root of 36 e squared t squared. So magyapon parehas gyapon sa number 1. So gipangita nato atong prime factors sa 126 and 36. Prime factors of 126. So 2 times 63 kani is equal to 126. 63 equal na to ang factor sa 63. So 9 times 7 is equal to 63. And then factor sa 9, 3 times 3 equals 9. So mao na ito ang prime factor sa 126 is 2, then 2 ka 3, then 7. So mo na ang 2, 2 ka 3, then 7. So another is 36. So 6 times 6 is 36. So 3 times 2 is 6, then another 6 is 2 times 3 is 6 gyapon. So mo na ang prime factor sa 36, 3, 2, 2, and 3. So 2 ka 3, then 2 ka 2. So, mo no, the same base siya, 2 times 2. So, yung exponent sa 2 is ma-plus. Mo ng 2 to the power 3. And then, 3 to the power 2, 3 squared, then 3 squared, magyapon, ma-plus gyapon ng exponent. The same base, the same base. You know, another 7. So, automatic 7. R squared times R. So, mo ng R cube. S squared times S squared, mo ng is 4. T times T squared, mo ng T cube. So, mo ka na. So, the same ya pag-process sa diri sa example. Sa atong first, the same process. So, atong ilahi. Dayon, kuan separate ya po nato para kita tag cancellation of the square root symbol guys. Okay, there is cube root of quantity of 2 cube times 3 cube. R cube is cube, T cube, the times the quantity of 3 times 7 s. Okay na atong gipagawas ang exponent aning na solution. Dayo atong gi-separate kini na square root na di na ma-extract siya, di na siya ma-cancel. So the final answer is 6RST cube root of 21s. Okay, another example about radical. Talking with rationalize the denominator of radical. So, for example, square root of 3 over 5 is equal to square root of 3 times 5 over 5 times 5 is equal to square root of 15 over, so square root of 25 is equal to square root of 15 over 5. So kung may na ganito analyze the denominator of radical, so first thing to do is atong magtangon ang radical symbol sa denominator. Another example, square root of 3 over 2x is equal to the square root of 3 times 2x over the 2x times 2x. We multiply both sides by denominator and numerator by 2x. So, mo na 3 times 2x is equal to 6x, the square root of 6x, then square root of quantity of 2x over 2. So, makancel siya. So, ma-rationalize na to ang denominator, no? So, square root of 6x over 2x. So, that is the final answer. So, another problem, 2 over the square root of x plus 3 square root of 5. So, to rationalize the denominator, we need to have a conjugate with this. The conjugate of this is the square root of x minus 3 square root of y, you know, and then we multiply the square root of x minus 3y both sides, the denominator and numerator. Square root of x times square root of x is equal to square root of x squared. Then square root of x times negative 3 square root of y is equal to negative 3 square root of xy. 3 square root of y times square root of x is equal to positive 3 square root of xy. 3 square root of y times 3 square root of y is equal to negative 9 square root of y squared. So 2 square root of x times 6 square root of 3 is makancel. Diyon. Minus 9 square root sa y squared is makancel yapon. So the final answer is 2 square root of x minus 6 square root of y over the x minus 9y. That is the final answer. To rationalize the numerator of radical, so for example, square root of x minus 1 over x minus 1 is equal to square root of x minus 1. So the conjugate of square root x minus 1 is the square root of x plus 1. Multiply numerator and denominator by this conjugate. So quantity of square root of x minus 1 times the quantity of square root of x plus 1 over the quantity of x minus 1 times the quantity of square root of x plus 1. Square root of x times the square root of x is equal to square root of x squared. Then negative 1 times positive 1 is equal to negative 1. And then square root of x times 1 is square root of x. Negative 1 times square root of x, negative square root of x, so it becomes 0. So ang mabili na is kanina lang, square root of x squared minus 1. Square root of 3 is makancel because of this exponent. So makancel yung exponent. So ang ma-remain niya is x minus 1 over the x minus 1 times the quantity of square root of x plus 1. We obtaining the answer of 1 over square root of x plus 1. Okay, our next topic is all about complex number. What is complex number? Complex number is an imaginary number is denoted as I. In some other areas in mathematical computations, especially in electronics and electrical engineering, it is denoted as J. The set of all numbers of the form E plus BI, where E is a real part and B imaginary part, are real number. Thus, imaginary number and its equivalent. So, I is equal to the square root of negative 1. I squared is equal to negative 1. I cubed is equal to negative I is equal to negative square root of negative 1. I to the fourth is equal to 1. So, for example, write the complex number in the standard form a plus bi. So, the square root of negative 9 is equal to the square root of negative 1 times 9, where square root of negative 1 is equal to I. So, I times square root of 9 is equal to 0 plus 3i. So, we write in the standard form a plus bi. The square root of 24 plus 5, the square root of negative 27 is equal to the square root of 4, square root of 6, plus 5 to the square root of negative 1 times the 9 times 3, where square root of negative 1 is equal to I. So, the answer is 2 square root of 6 plus 15 square root of 3i. Let's talk about the sum, the difference, and the product of the two complex numbers. So, example, find the sum, difference, and product of the complex numbers 5 minus 4i and negative 2 plus 6i. So, solution. So, this is sum 5 minus 4i plus quantity of negative 2 plus 6i is equal to the 5 minus 2 plus quantity of 6 minus 4i is equal to 3 plus 2i. So, the difference, the difference, so atong gi minus, no? So, quantity of 5 minus 4i minus the quantity of negative 2 plus 6i is equal to 5 minus 4i plus 2 minus 6i is equal to 5 plus 2 plus quantity of negative 4 minus 6i is equal to 7i minus 10. So, that is the answer. So, next, the product is the process by multiplying the product, no? So, 5 times negative 2 is equal to negative 10. 5 times 6i is equal to 30i. Then, negative 4i times negative 2 is equal to 8i. Then, negative 4i times positive 6i is equal to negative 24i squared. Negative 10 plus 30i plus 8i, I to the power 2 is equal to negative 1. Minus quantity 24 times the negative 1. So, the next, negative 10 plus 30i plus 8i plus 24. Final answer is 14 plus 38i. So, another example, find the quotient of the complex numbers 5 minus 4i and negative 2 plus 6i. So, this is the given, no? Find the quotient. Next. So, the conjugate of the complex a plus b is a minus b. So, for example, no? For 3 plus 2i is the conjugate of 3 minus 2i. Solution for this example. So, 5 minus 4i over the negative 2 plus 6i is equal to
quantity of 5 minus 4i, quantity of negative 2 minus 6i over the quantity negative 2 plus 6i times the quantity of negative 2 minus 6i. So, we have already the conjugate of this negative 2 plus 6i. So, 5 times negative 2 is 10. Then 5 times negative 6i is negative 30. Then negative 4i times negative 2 is negative 8. Then negative 4i times negative 6i is 24, positive 24i squared. Then sa denominator naman is negative 2 times negative 2, that is positive 4. Dayon, negative 2 times negative 6, that is positive 12i. Then 6i times negative 2, that is negative 12. Then 6i times negative 6i, that is 36i squared. Negative 10 minus 30i plus 8i plus 24 times negative 1. Remember that I squared is equal to 1. So we get the value, we change the value of I squared into negative 1. For the 4 minus 36 times also the I squared in denominator, we change into negative 1. So the result is negative 10 minus 30i plus 8i minus 24 over the 4 plus 36. Negative 10 plus negative 24 is equal to negative 34. Then negative 30 plus 8 is equal to negative 22i. Final answer is negative 17 over 20 minus 11 over 20i.
Another example about complex numbers applying law of exponents to positive integers. So remember that I squared is equal to 1, or I is equal to square root of negative 1. So I3 is equal to I squared times I is equal to I squared, where I squared is negative 1. So I3 is equal to negative I. I4 naman, so I to the power 4, so I squared times I squared. So remember this, I squared is equal to negative 1. So negative 1 times negative 1, so equals 1. So therefore I squared I to the 4 is equal to 1. Next,
I5 is equal to I4 times I. Remember I4 is equal to 1. So I to the power 5 is equal to I.
I6 is equal to I to the power 4, or I to the power 6 is equal to I to the power 4 times the I to the power 2. So remember I4 is also positive 1 and I squared is also negative 1. So 1 times negative 1 is negative 1. So therefore I6 is equals to negative 1. So for example, first I to the power 9. So atong gi-separate daan, no, ilain atong I. So I to the power 8 times I. So atong gibahin og iyang exponent is atong gibuwag og ika-upat. So I to the power 4 times I to the power 4 times I. So dali ra kay na pagkuan nato, no, ato rang so kung sa nag-factor out atong kung ang prime kung nag-prime factors so atong gi-factor out or gikuha na to ang prime factors, no, sa exponent in terms of exponent diri sa complex I. So atong gikuha ang iyang prime factors, no, kay we all know that I4 is equal to positive 1 man. So okay, 1 times 1 times I. So therefore I9 is equal to I. Question number 2, I to the power 23. So I to the power 23. So una na to diya is atong ano, ang I23 is equal to I20 minus I2. So times the I. So 20. So mura to kay gapon og nag-exponent ani 20 plus 2 plus 1, exponent sa I is 1 man, so 23. So it easy atong solusyon, no? 4 times 5. So kini is multiply man ang exponent na to ani. So 4 times 5 is 20 man. So take note that I to the power 4 is 1 man, so automatic I to the power 5. So and then dili naman, so I squared is take note that I squared is also negative 1. So negative 1. So the remaining is may siyang negative I. So therefore I23 is equal to I. For 3 I over I to the power 3. So manang given, no? So solusyon. So atong gibuwag ang kuan. So di ba ato ni pasaka may man siyang I to the power negative 3. So atong ana is reciprocal atong gi 1 over I to the power 3 man siya. So mo to atong gibuwag kay bawon ta compile value ani sa I squared is negative 1 man. So times I. So to obtain, para makuha nimo ang value sa 1 over I3, so we rationalize the denominator. Remember that when you multiply, so dapat naka-conjugate siya, no? Naka-conjugate yung conjugate sa denominator. So conjugate sa negative I, so positive I. So negative I times I is negative I squared. Then numerator pod also i-times na nimog I. So I over negative I squared is equal to I, because I squared is negative 1 man. Negative 1 man ang I squared, so negative 1 times negative positive is the final answer.
So, quadratic equations. An equation that can be written as ex squared plus bx plus c is equal to 0, where e, b, and c are real number constant. So, where e is not equal to 0, it is called a second degree polynomial or quadratic equation in the variable of x. The word quadratic comes from quadrate, meaning square of rectangular. This is the standard form in quadratic equation. So, ex squared plus bx plus c is equal to 0. So, this is the formula of x is equal to negative b plus minus square root of b squared minus 4ec over 2e. So, remember that. So, for example, so this is the example of the quadratic equation written in the standard form, where e, b, and c here is the real number constant. For example, find the solution set of each equation. So, for example, letter e, 1 plus 5x over 6 is equal to 2x squared over 3. So, we need to cancel out the numbers of the denominator, so 6 and 3. So, the common factor is 6, no? We multiply by 6. 6 plus 5x is equal to 4x squared. So, okay, to remove the negative sign here, so we multiply the negative 1. So, negative 1 times negative 4x squared is equal to positive 4x squared. So, negative 1 times 5x is equal to negative 5x. So, then negative 1 times positive 6 is equal to negative 6. So, negative 1 times 0 is equal to 0. So, we have the standard form of the quadratic equation. So, now we can solve by using the completing the square. So, okay, I will check if this completing square is correct. X times 4x is equal to 4x squared. Then x times 3 is equals to 3x. Negative 2 times 4x is equal to 8x. Negative 2 times 3 is equal to negative 6. So, bring down 4x, then bring down 5x, because positive 3x minus the 8x is equal to 5x. So, 8x here is the bigger, so we can write also the sign. Then bring down the negative 6, so that is correct. Our completing the square is correct. So, to obtain the solution set of this equation, okay, 4x plus 3 is equal to 0. So, 4x is equal to negative 3, so we transfer the 3 to the left side, so it becomes negative. So, to find the x, so where x is equal to negative 3/4. So, and then the another set of this equation is x minus 2, so we transfer to the right side. So, x is equal to 2. So, now we can have the final solution set. Let's another example given. So, 3x over x plus 2 is equal to x plus 4 over x. So, solution. Okay, we have already the solution. We need to multiply the x times the quantity x plus 2 to remove the value of the denominator. If you multiply here the x times the quantity of x plus 2, so where x plus 2 is to be cancelled, you know, the remaining is x, so money, no, 3x times x is equal to 3x squared. If you multiply x times x plus 2 to x plus 4 over x, so makancel ang yang is ma-remove ang x, you know, remain ang x plus 2. So, where x times x is equals to x squared, 4 times 2 is equal to 8. So x times 2 is 2x. 4 times x is 4x. So 4x plus 2 is equal to 6x. So we transfer to the right side. When we transfer x squared, it becomes negative x squared. When we transfer 6x, it becomes negative 6x. When we transfer positive 8, it becomes the negative 8 is equal to 0. So the same sign, so we minus with that because of negative x squared. So 2x squared minus 6x minus 8 is equal to 0. So in this equation, we have to reduce by multiplying by 1/2. It becomes a x squared minus 3x minus 4 is equals to 0. So the factor out or the completing the square is x minus 4 and x plus 1. And then, so this is the solution set for this given example with the use of quadratic formula. For example, for this equation, 4x squared minus 5x minus 6x is equal to 0. So this equation did not written in standard form in quadratic equation. You cannot solve, you cannot distribute the real number constant in the quadratic formula. So let us distribute the following given E, B, and C to the quadratic formula. We have obtaining the two solution set because of this positive negative sign, or plus and minus. So we separate the another set of these equations. We obtain x is equal to negative times the quantity of negative 5 plus square root of a quantity of negative 5 to the power 2 is 4 times 4 times negative 6 over the 2 times 4. So it becomes a 5 plus square root of 25 plus 96 over 8. And then 5 plus square root of 121 over 8. And then the final answer is x is equal to 2. Another solution set, okay, the same process, but there is minus. So this is the two solution set for this equation. When we talk about the quadratic equation, so we have to learn also the nature of roots. The discriminant of b squared minus 4ac determines the nature of the roots of a quadratic equation. When b squared minus 4ac is equal to 0, roots are real and equal. One root only. So when b squared minus 4ac is greater than 0, so roots are real and unequal. So another rule, when b squared minus 4ac is less than 0, roots are imaginary and unequal. So for example, 4x squared minus 12x plus 9 is equal to 0. So we find the discriminant, no? So by use this formula, so b squared minus 4ac is equal to quantity of negative 12 to the power 2 minus 4 times 4 times 9. So the discriminant is 0. So therefore, the roots are real and equal. So one root only. We prove with this by the use of completing the square. So quantity of the completing of the square for this equation is this. So 2x minus 3 times the quantity of 2x minus 3 is equal to 0. So therefore, the one root here is equal to 3 over 2. Okay, no? This is the only one root. So this equation is real and equal, but one root only. So another 3x squared minus 2x minus 6x is equal to 0. So we use this formula, b squared minus 4ac is equal to quantity of negative 2 to the power 2 minus 4 times 3 times negative 6. So the answer is 76. The discriminant is positive. It means the roots are real and unequal. Another example, 2x squared plus 6x plus 7 is equal to 0. So b squared minus 4ac is equal to 6x to the power 2 minus 4 times 2 times 7. So therefore, the answer is negative 20, but the discriminant is negative, so therefore the roots are imaginary and unequal. Let's talk about the properties of the roots. Let R1 and R2 be the roots of a quadratic equation. When the two roots are added, so R1 plus R2 is equal to negative B over E. When the two roots are multiplied, R1 times R2 is equal to C over E. For example, if 1/3 and negative 3 over 2 are the roots of a quadratic equation, find the equation. Solution. R1 is equal to 1/3 and R2 is equal to negative 3 over 2. So, we use this formula. R1 plus R2 is equal to negative B over E. Then, we substitute the R1 and R2. So, it becomes 1/3 plus quantity of negative 3 over 2 is equal to negative B over E. So, where B is equal to 7 over 6E. R1 and R2 is equal to C over E. So, 1/3 the quantity of negative 3 over 2 is equal to C over E. So, where C is equal to negative 1 over 2. So, where the value of C is equal negative 1/2 E. So, we use this standard form of the quadratic equation. So, we substitute B and C for this equation. So, E squared plus quantity of 7 over 6E x plus quantity of negative 1/2 E is equal to 0. So, 6 over E times E squared. So, remain ang 6, makancel lang iyang E. 6 over E times 7 over 6E is equal to 7x. 6 over E times negative 1/2 E is equals to negative 3. So, 6 over E times 0 is equal to 0. This is the quadratic equation of these two roots, 1/3 and negative 3 over 2. We have the alternative solution for these two roots of the quadratic equation. X times x is equals to x squared. X times 3 over 2 is equals to 3 over 2x. Negative 1/3 times x is equals to negative 1/3 x. Negative 1/3 times 3 over 2 is equals to 1/2. Then, equate to 0. To cancel out the fraction, so we multiply both terms by 6. So, 6 times x squared, so 6x squared. 6 times 7 over 6x is equal to 7x. 6 times negative 1/2 is equals to negative 3. 6 times 0 is equal to 0. So, we have the same answer equations. Next topic is all about absolute value. So, if E is a real number, the absolute value of E denoted by absolute E is E if E is non-negative, negative E if E is negative. With the symbols, we write absolute value is equals to the positive E and negative E. So, E if E is greater than or equal than 0, negative E if E is less than 0. For example, absolute value of 6 is equals to 6. Absolute value of 0 is equals to 0. Absolute value of 6 is equals to negative times negative 6 is equals to 6. Take note that negative 6 is less than 0. We multiply by negative. The result is 6. From this graph indicate the distance left and right. So this is the origin. Take note that absolute value of a number can be considered as a distance without regard to the direction left or right from the origin. On this figure, as a distance on the real number line, absolute value E minus B units can be interpreted as the distance between the A
and B regard to direction. A minus B, if A is greater than or equal to 0. Okay. If A daw is greater than or equal than 0, so there, no? So the distance from here to here. And then next is where negative times the quantity of A minus B if E less than 0. So example number 2, show the points correspond to the numbers negative 10, negative 7, negative 5, negative 3, 0, 3, 5, 7, and 10 on the real number line. Find the distance between U and V in each of the following cases. So, money ang given to determine the distance. So, natay graph, this is the origin sa for the given. U is equals to 10, B is equals to 3. So, yun na, solution. Absolute value of U minus B is equals to absolute value of 10 minus 3. So, 10 minus 3 is equals to 7. Then the distance is 7. So, let's check. So, if U nimo is 10, then if V nimo is positive 3. So, okay, the answer is correct. The distance from 3 to 10 is 7. Then, if U nimo is 5, then if V nimo is negative 3, so 5 minus quantity of negative 3 equals the absolute value of 8. So let's check the graph. So from 5 to negative 3, the distance is 8. So sakto na. You count starting with this 1, 2, 3, 4, 5, 6, 7, 8. So the answer is correct. Next, if U is negative 3, negative 5, P is negative 5. So the answer, negative 3 minus quantity of negative 5 is equals to the absolute 2 is equals to the distance is 2. So let's check distance. Next, so if U is 3 and B is positive 7, so 3 minus 7, so negative 4. So absolute value of negative 4 is 4. So let's check. Okay, sakto. From 3 to 7, the distance is 4. Next, if U is negative 7 and B is equals to 0, so, okay, negative 7 minus 0 is equals to the absolute value of negative 7 is 7. So, let's check. So, negative 7 to 0, so the answer is correct. Okay, last, negative 10, if U is negative 10 and V is negative 7, so negative 10 minus negative 7 is equals to absolute value of negative 3. So the distance daw is 3. So let's check. So let's talk about the another example of the absolute value. So for example number 3, find the solution set of the equation absolute value of 3x plus 5 is equals to 9. So remember this these types of formula. So solution, 3x plus 5 is equals to 9, then 3x is equals to 9 over 9 minus 5, then where 3x is equals to 4, then where x is equals to 4 over 3. Another is negative e, so ato na e multiply by negative. So negative times quantity of 3x plus 5 is equals to 9, so multiply nimo no. So negative 3x, so negative 5, i-transfer nimo ang 5, so may mga positive, so the remaining is negative 3x is equals to 14 because 9 plus 5 is 14, so where x is equals to negative 14 over 3. The solution set of this equation is 4 over 3 and negative 14 over 3. So that is the answer. Example is find the solution set of the equation absolute value of 2x minus 3 is equals to absolute value of 7 minus 3x. So solution. So 2x minus 3 is equals to 7 minus 3x. 2x plus 3x is equals to 7 plus 3. Then 5x is equals to 10. Then where x is equals to 5, 10 over 5. And then the result is x is equals to 2. So another is 2x minus 3. Okay now.
Another kanang solution set is kini negative a, so we put here negative also, or pwede sa kana ari nimo butang negative, or 2x minus 3 is equals to negative 7 plus 3x. 2x minus 3x is equals to negative 7 plus 3. 2x minus 3x is equals to negative x. Negative 7 plus 3 is equals to negative 4. So we divide by both side negative, so the result is x is equals to 4. Solution set of the equation is 2 and 4. Our last topic is polynomial functions. Polynomial is an algebraic expression involving only non-negative integers powers on one or more variables and containing no variable and a denominator. So, a polynomial of degree n is a function of the form if function of x is equals to e and x to the power n plus e n minus 1 x to the power n minus 1 plus and so on plus e 2 x to the power 2 plus e1 x plus e0. So, a polynomial can be considered as the sum of finite numbers of terms. For example, 5x squared minus 8x plus 2 can be written as 5x squared plus quantity of negative x plus 2. So, this is the term, this is the term, another term, this is the another term. So, there are types of polynomial functions. So, first is the monomial, only one term. So, for example, 2x, 3x squared, y to the power 5. Next is the binomial. If it has two terms, example 6x squared plus 8y squared. So trinomial if it has three terms. So example 5x squared minus 8x plus 2. So the degree of a polynomial is the same as the degree of the term with the highest degree in the polynomial. For example, 3x squared y to the power 5, the degree is 7. 5x squared minus 8x plus 2, the degree is 2. 6x squared y cubed minus 4x to the power 4 plus 2y, the degree is 5 because the highest degree, only highest degree, 2 plus 3, so 5. These three special products is called the square binomial. Another special product is called the difference of two square because x to the power square minus y squared. So this is also the square of binomials, then the cube of binomial, the square of trinomial. You know, let's study with this. Some of them is can be used the another topic of algebra. So mostly the square of binomials. Of addition of polynomials. Given 4y cubed plus 7y squared plus 3y minus 8 plus 6y cubed minus 2y squared plus 4. 4y cubed plus 6y cubed equals 10y cubed. Positive 7y squared plus negative 2y squared is equal to 5y squared. Bring down 3y, so negative 8 plus positive 4 is equals to negative 4. So remember the sign, when the bigger the number, the sign we choose. So there is dako man number 7, so dapat positive. Dako mag kanang value ang 8, so yan there is negative man, so dapat negative pa siya. Another example, when you subtract the polynomials. For the given 2e cubed plus e squared plus 4e minus 3 minus 4e cubed minus 8e squared plus 2e plus 6. So remember the variable is the same exponent. Okay, no? The same exponent. You can add the variable if they are the same exponent.
So, subtract. When you subtract, first, you can change the sign of this subtrahend. Positive 4e cubed become negative 4e cubed. Negative 8e squared become positive 8e squared because negative times negative is positive. And then positive 2e is negative 2e because negative times positive is negative. Then positive 6, so negative times positive 6 is negative 6. Okay, so now this time you can add 2e cubed plus negative 4e cubed is equals to 2 negative 2e cubed, and then e squared plus positive 8e squared, the result is 9e squared. 4e plus negative 2e is equals to positive 2e. Negative 3 plus negative 6 is negative 9. So if you can add the same sign, for example, so you obtain the negative sign. Remember, if you multiply, positive times positive is positive, positive times negative is negative, negative times negative is positive, negative plus negative is negative. Example, find the product of quantity of 3x squared minus 2x plus 1 times the quantity of 3 plus x minus 4x squared. Okay. Solution. Negative 4x squared times 3x squared equals negative 12 x to the fourth, and then negative 4x squared times the negative 2x is equal to positive 8x cubed. Negative 4x squared times the 1 is equals to negative 4x squared. X times 3x squared is equals to 3x cubed. X times negative 2x is equals to negative 2x squared. Next, x times 1 is equals to x. Next, 3 times 3x squared is equals to 9x squared. 3 times negative 2x is equals to 6x. 3 times 1 is equals to 3. Then the final answer is negative 12x to the fourth plus 11x cubed plus 3x squared minus 5x plus 3. Another example, find the quotient of this 6x squared plus 13x minus 28 over 3x minus 4. Mga nagitawag na itong dividend. Yan. Divisor. Dayon, the answer is quotient. So, 3x divided by 6x squared equals 2x. 2x times 3x is 6x squared. 2x times negative 4 is negative 8x. So, 3x divided by 21x minus 28. So, equals 7. So, 7 times 3x is equals to 21. 7 times negative 4 is negative 28. So, minus. So, is equal to 0. So, the final answer is 2x plus 7. We have another example. Reduce of the following rational expression to the lowest term. So, example given, 18x squared plus 9xy minus 2y squared over 9x squared minus 4y squared. Solution. So, we need to find the factor with this. So, the quantity of 6x minus y times the quantity of 3x plus 2y is the factor of 18x squared plus 9xy minus 2y squared. Quantity of 3x minus 2y times the 3x plus 2y is the factor of 9x squared minus 4y squared. We recall with this on how to factor with this product. 6x times 2y is equals to 12xy. Y times 3x is equals to 3xy. So 12xy minus 3xy is equals to 9xy. So 6x times 3x is equals to 18x squared. And then negative y times 2y is equals to 2y squared.
Next, 3x times 2y is equal to 6y. Then, negative 2y times 3x, 6xy plus 6xy is equal to 0. So, 3x times 3x is equals to 9x squared. Negative 2y times 2y is equals to negative 4y squared. We have the same the value of denominator and numerator. So, let us cancel. So, pwede na siya makancel. Next, the final answer is quantity of 6x minus y over 3x minus 2y. So, note, incorrect cancellation of variables. For example, quantity of x minus 1 over x. Dayon, iyang gi-cancel ang x sa numerator o ang x sa denominator. So, iyang gi-cancel. So, the result niya is negative 1. So, that is the big wrong. You cannot cancel the x minus 1 over x because x minus 1 is a binomial function. Quantity of x plus 2y over 2y. So, ang kwanda is the same na lagi po, no? Makancel ang 2y. So, the answer nimo is x. So, that is the big wrong. So, another example. X squared minus 4 over x squared. That is also the big wrong. Okay, another example. Note that to multiply the rational expression, we use the following property of diffraction. First, E over B times C over D is equals to EC over BD. So, mao ni, no? Natay roll. Then, solution. So, x minus 5 over 2x minus 3, quantity of 2x plus 3 is the factor of 9x squared minus 9. Another is 2x plus 3 times 2x plus 3 is another factor of 4x squared plus 12x plus 9. Then, quantity of x minus 5 times the quantity of 2x minus 1 is another factor of 2x squared minus 11x plus y. Then, so we think that they have cancellation. We have the same value in numerator and denominator, which is 2x plus 3, dayon x minus 5.